Today we're going to look at some information with scatter plots and how scatter plots are correlated with information that we collect for them. So remember, a scatter plot just shows the relationship between two variables on a graph, where each ordered pair is an outcome of the data. So we've talked about correlation before, and we've identified positive, negative, and no correlation. So if I looked at these scatter plots, we could easily identify some of these now with those phrases. So like this first one I know is negative. It's negative because the data is going down. As one is increasing, as my values down here are increasing, these ones are decreasing. This continues to be negative. Continues to be negative. Here there's no real relation. Now the data is starting to trend positively. Still positive, and more positive. So now that we have these languages for negative, positive, and no relationship, we can even get more specific and describe just how correlated some pieces of data are. Because if you notice, these three that are negative, they all are negative, but one of them looks more like the data is together in a nice straight line, and the other ones are a little bit more spread out. Same thing with the positive values. Some of these are more spread out, and then one piece of the data looks pretty close to each other. So how one person may describe a scatter plot compared to another is very subjective. To quantify the strength and association of the linear relationship between two variables, we use a measure called correlation. Let's write the correlations for each of the scatter plots to examine how correlation works. So I wrote those down for you already. Here are the correlations for each of these scatter plots. And maybe you noticed something about the numbers. When we said negative, these values gave us negative. Positive, these values gave us positive. So what makes something more towards this end or more towards this end is based on how close the data is together in a nice straight line. So for correlation, it's kind of a spectrum. So something with a correlation of -1 is all the way over here at the end, and that's that perfect straight line where the data fits nicely in a straight line. That is a correlation of -1. So we call this a perfect linear relationship. So anything that's in that nice straight line that's negative is your perfect linear relationship, -1. Things between 0 and -1 that are still negative have a strong linear relationship. So they're not perfect, but they look very close to having that -1. So in this example, -0.8. So it's close to -1, but it's not exactly -1. Things that don't really have a strong relationship are called a weak linear relationship. So these are numbers that are closer to 0. So in our example, we had -0.3. There is a little bit of a linear relationship here, but it's not that great. So this value is a little smaller, or more negative, less negative. This one is closer to 0, and this one is closer to 0. So when you're closer to 0, you really don't have that nice relationship. It's kind of hard to tell, other than that it's negative or if it's positive. Once you start getting more positive, the same idea, you get a strong linear relationship again. And that happens as your numbers get closer to 1, +1. And then at the end again, you get a perfect linear relationship. So underneath our little scale here, we have negative correlation implies one value increases as the other decreases. No correlation implies that the values don't seem linked at all. And positive correlation implies that they increase or decrease together. So as one increases, the other increases as well. Or if one decreases, the other decreases. So let's look at some examples. So now we have these correlation coefficients. So we're going to use numbers now to suggest what the values are for the correlation. So the closer it is to a nice straight line, it's either going to be -1 or +1. So if they're positive, they get closer and closer to 1. If they're negative, they get closer and closer to -1. So let's look at some examples. Look at the two scatter plots below. Which scatter plot has the negative correlation? So the negative correlation here is scatter plot B. Which scatter plot has a strong linear relationship? So which one has a more strong linear relationship? Is it going to be A or B? In this case, I think it's going to be A, because you can see the points are a little bit closer together. There's more of a line that's visible that you could draw through this, versus B, which is the data more spread out. So A has a stronger linear relationship because the points are closer together. So what do we think the correlation would be for each of these? Well, this we're saying is a strong linear correlation, and it's positive, so it's going to be a number that's close to 1. Not exactly 1, because that would be a perfect relationship. So for scatter plot A, I think that correlation is going to be around 0.85. It's not perfect, but it's close to 1. And we use the letter R to represent the scatter plot, the correlation factor. For scatter plot B, this is negative, so I know my scatter plot correlation is going to have a negative value. And then this one's not as close together. So because it's not as close together, it's going to be a number that's a little bit further away from -1. So I'd say about -51, -0.51 for that correlation. So the correlation coefficient, this number, just tells you how closely related are the data points. If closer it is to 1, it's positive. It looks like a line. The further away from 1, the less it's going to be with the points near each other. Alright, so flip it over to the back. So if I gave you a scatter plot and it had a correlation of -0.95, what does that tell us about the scatter plot? Well, it tells us a couple of things. First, the scatter plot is negative. So when I look at the points, it would tell me that it's going down. And second, because the scatter plot, that number for the correlation is so close to -1, it has a strong linear relationship. So if I was going to draw a scatter plot that could represent -0.95, I'm just going to create some points that give me a nice negative line where the points are very close to each other. So it's got to be very close to being a perfectly straight line to have that high of a correlation coefficient. So that's it for scatter plots. So when you look at a scatter plot, you should be able to use some language. Is it strong or weak? Is it positive or negative? And now you should be able to tell me what the coefficient could be for that value. So the more positive it is, the closer that has the points together, it would be a strong correlation with 1. And the negative it is, with the points close together going down, to be -1. So we use that scale to help us get through correlation coefficients. So let's try that homework to answer these questions.